Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. Friends, in this session again we will create our brand new project where we are going to create our own custom object detection model, and then we will create a counter. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we will create again new project where we are going to create our own custom object detection model using YOLOv12, and then we will create a counter. So for that I have created a new repository. I will mention the link. Simply copy paste the link inside web browser, then go to the code and click on download zip. As we always do, we have our repository ready. Inside downloads folder, just right click to the repository, click on extract all, click on extract. That's it. It will extract our repository, which is YOLO counter main, and then this is what our video file. So let's just watch our video file first. As you can see, this is what our video file, and we have basically lots of packages moving on conveyor belt. So our goal is to detect these all boxes. So first we will create our own model which detect all these boxes, and then with the help of a line, with the help of this horizontal line, we will create a counter. Simple. So first we will create our own custom object detection model. So this is basically our video file. Simple. So for custom object detection we will use Roboflow, and we will send this video file to Roboflow. So let's just open Roboflow. I have already opened it. Just log in with your Gmail ID, click on new project, mention any name, and on annotation group mention any annotation group as a name. I have mentioned just like object. Then we will use a project type which is object detection bounding boxes. So just click on it, click on create public project. It will create our new project. Then click on select files, and we want to simply add here our file. So download, and then we have our repository which is YOLO counter main, and inside that we have our file which is the video file box.mp4. Click on it, and it will upload our video file on our Roboflow. So we uploaded our video file. Now here we want to select how many images we need. So right now, as you can see, it says the 9 images, but 9 images is not enough. So I will simply move this circle. As you can see, you can move this, and then here you will see that the number of frames. So right now I will go with, let's say, 57 images. Simple. So 57 images is more than enough. Click on choose frame rate. Now it will create 57 images using video file. So friends, now we have our images. As you can see, just click on save and continue. So we have now our images. Now how do you want to label your images? Of course we will use manually. So click on start label ing, and then here you have to mention your Gmail ID. So it will assign all the images for your Gmail ID. Click on assign to myself, click on start annotating, and now then we have our annotation tool ready. So we will go with the bounding box tool. So now let's just draw the bounding box on the box like this way. Okay, and then here you will see the annotation editor. So simply mention here box, because this is a box. So create class box. Then let's just draw here. Okay, simple. Click on save, and then let's just draw on this box. Click on save. Now there is no need to draw a rectangle on other boxes, because we will use this tool, box prompting AI labeling. You have to first draw manually bounding box on some of the objects. Like we have here boxes, so I have drawn only 1 2 3 rectangle. Now after that we will use this tool, box prompting. So just select it. Now it will automatically prompt all the boxes, as you can see. So here we can simply use the confidence level. So let's just say 60%. So if I go like this way, it's good. So 85% confidence is really good. Okay, and now it's detecting all the boxes. Now click on approve, and now as you can see we have all the boxes automatically detected. Now go for next image. So from next image, now there is no need to draw a bounding box. With the help of this tool, it will automatically select all the boxes. Here it is, as you can see, this box is not selected. So simply you can change the confidence level. You can change it, as you can see. You can change the confidence level. It will detect the boxes. So now go for next image. Again same way, it will automatically detect all the boxes. As you can see, it is detecting all the boxes. Click on approve. Go for next image. Again it will automatically detect all the boxes. Click on approve. So now this is how I will use this tool, and I will complete annotation process. So friends, I have completed annotation process. As you can see, this is what our last image, 56 out of 56. I have used the bounding box tool for first drawing the bounding box. With the help of bounding box tool, I have just selected 3 boxes, and then I have used this tool, box prompting. With the help of this tool, it will automatically prompt the box for your object. Okay, so this is how I have draw a annotation. Now we have done with annotation process. Now click on the project name YOLOv12, and then here you will see unannotated 0 and annotated 56. Click on add 56 images to dataset, and then we have here method. As you can see, the method, just click on it, and then we will use split images between train, valid and test option. So just select it, that option, and it will automatically split the images in between train, valid and test. Just click on add images. Now it will add our images. Let's just close the window. Done. And in dataset, as you can see, we have 56 images. Now click on versions, and then we will click on continue, then continue, then create. Now it will create our dataset. Now we want to open our Google Colab. So let me open Google Colab. So friends, I have opened the Google Colab. Just click on upload, click on browse, and go to the repository. Our repository YOLO counter main. Inside that I have mentioned Colab file. Let's just wait for uploading our file. So we uploaded our Colab file. Go to runtime, change runtime type, select Python 3, select T4 GPU, click on save, and then click on connect. So we connected. Now click on first cell, import OS, then click on next cell where we install Ultralytics. So friends, we successfully install our Ultralytics package. Now we will go for next cell. Just click on it, play button. It will import the packages. Then we will cross check if Ultralytics is successfully installed or not. So for that we will use YOLO12s.pt model, and the image which we will use from the Roboflow, the image name is basically talk.jpeg, and it will detect the object using YOLO12s.pt pre-trained object detection model. And inside that image we have one car, one dog and one handbag. It means we successfully install our Ultralytics. Now custom training. So here from to YOLO12, this is basically old code. So we want our new code. So we will move on where we left our Roboflow. So this is the page where we left. Simply click on download dataset, and here we want to select txt. From txt we will select YOLO12. You can select YOLOv11, YOLOv9, YOLOv8, YOLOv5. anything. We will go with YOLOv12. So YOLOv12, and then we will click on show download code. Just click on continue. So friends, this is what our code. So simply we will copy it from to YOLOv12. Just copy it, and we will press Ctrl+C, so it will copy, and then we will open our Google Colab. Again we will copy from to YOLOv12, delete it, and then just press Ctrl+V. It will paste our new Roboflow code. Okay, so just copy it and then remove the old one code, and then just press Ctrl+V. It will paste our new code. Now let's just run the cell. So we completed our cell. It will create dataset directory, and inside that it will copy paste our project folder. So let's just click on this small folder icon. We have dataset folder, then we have our folder, then we have our data.yml file. Double click on it, the file, and here it is. As you can see, this is what our class name, which is the box, and this is the folders where we have our files. So we want to mention the path. So for train, so this is the train folder. Click on the three dot, copy path, and remove the old one. Ctrl+V, then val. So val is basically valid. Click on three dot, copy path, remove the old path. Ctrl+V, then we have test. So test folder, just move to the test. You will see there is a three dot. Click on it, copy path, and then remove the old one. Ctrl+V, paste it. Now we mention the changes, so we want to save the file. So right now, as you can see, I am inside this data.yml file. So here simply I will press Ctrl+S, and it will save our data.yml file. So we successfully save it. Now go for next cell, and here this is what our training cell. Here we start our training. So we want to mention the data.yml file. So data is equal to, this is the data.yml file. So we want to mention the path. So data.yml, again three dot, click on it, and copy path, remove the old path. Data is equal to, remove the old path, Ctrl+V, paste it, new path. Now let's just start our training. So friends, our training is started. So let's just wait to complete our training. So friends, we completed our training process, and now again we will click on this small folder icon. The model save inside runs, detect, and train. As you can see, results save to runs, detect, and train. So we will go in runs. We have detect, then we have train, then we have weights, and inside that we have base.pt. So go to the three dot, click on it, and click on download. It will download our model. So we downloaded our model. Now let's just close the web browser. We have done. Now let's just open file manager, downloads. This is what our model. Right click, cut it, move the model inside YOLO counter main folder. Open main.py with the help of Sony Python IDE. Here I will mention the model name. Model is equal to base.pt, and the video file name, which is I think box.mp4. Yes. So here I will mention the video file name. That's it. And then this is basically the Ultralytics basic code for object detection. So now let's just run the code. First we need to install the packages. So go to the tools, manage packages, search for opencv-python, hit enter. First package, click on install button, done. Then we will search for Ultralytics package, click on install button, done. It will install Ultralytics package. Then we need CVZone package, search for CVZone first package, click on install button, done. It will install CVZone. So we need OpenCV-Python, Ultralytics and CVision. Now let's just run the code. So there is a typo mistake, okay, no worry. So I will mention base.pt. So friends, as you can see, we are detecting the boxes. As you can see, this is what our result. This is what our result, friends. It's detecting boxes. This is what our own custom object detection model which we created. It's work really perfect, as you can see. So now our goal is to detect the object. So we detected object. Now we will create a counter. So for creating counter, we will use a single line as I mentioned, and we will use the horizontal line. So we will draw the line like here. Let's just say we will draw the line here, over here, okay, here, and then we will create the counter. So for drawing line we need 2 points. So for that we have here mouse event function, cv2 dot event mouse move function. So if I move my cursor on the frame, inside shell we have coordinates, of course. So if I go here, let's just say here, so the coordinate is basically 0, 2, 9, 0. 0, 2, 9, 0 is my cy. So 0 is basically the x coordinate of the start line, and 290 is basically the y coordinate of the start line. So I need here y coordinate. So I will mention 290 is basically my line y coordinate. So line y is basically 290. Now with the help of this line y we will draw the line. So here cv2 dot line, but first let me show you here one more thing. If I print here, print frame dot shape, frame dot shape, if I save the code, if I run the code, so as you can see, this frame dot shape printed the height of the frame and the width of the frame, height and the width. So for this we have the line y coordinate which is the same. So we need here x coordinate. So x coordinate is basically the 1020. So if this is the 0, then this is the 1. So we will use frame dot shape 1. Okay. So now cv2 dot line, and inside that we will use 0 start point x coordinate and then line y. So line y is basically our y coordinate 290. So line y we want to mention here like this way. First frame, we will draw the line on the frame, and then we want to mention here a line start point xy coordinate, then end point xy coordinate. So end point x coordinate, which is basically our frame dot shape first coordinate. This is the 0 and this is the first. So frame dot shape, and we will mention 1, and then we will mention line y, and then we will mention the color. So let's just say 255 white, and then thickness 2. Done. Now if I save the code, all the way good. Line y 0, frame dot shape 1, line y, this is what our color and this is what our thickness for drawing line. So as you can see, there is a white color line. which we will use for counting the boxes frequency. Simple, as you can see. So now we need here detected object center point. So detected object center point is basically x1 plus x2, y1 plus y2. So here I will mention cx is equal to int, then x1 plus x2 divided by 2, cy is equal to int y1 plus y2 divided by 2. So we have now cx and cy. So cv2 dot circle, we will draw the circle on the frame. Then we need cx and cy, then the radius, which is the 4, then the color 255, let's make it blue, so 25500, and then we want to fill the circle, so -1. Now each box we have the center point because we create here cx and cy, and we highlighted the center point. As you can see, there is a blue color center point for each box. Each box we have blue color center point. Simple, each box we have blue color center point, as you can see. So when this center point touch the line, we will create a counter. So what we will do, we will simply shift the line, because here, as you can see, there is a collision in between some boxes. So we will simply, let's just say I will fix the line over here. So 3 to 6, so I will mention here 3 to 6. You have to check where you want to create a perfect counter. So 3 to 6, just change only the line y. All the things are same because we mentioned the variable, so you have to only change the y coordinate, it will automatically change the line. As you can see, it's perfect. Now here, as you can see, it will perfectly count. Okay, it will perfect count. Simple. So now what we will do, we will use the track ID. We will use here track ID. So for track ID, we have the track ID over here. So if because we are putting here label, so that's why it says the label, means it show the box. So if I mention here str and the track ID, so now it will show the track ID on each object. Each object we have track ID. As you can see, this box we have 4, this box we have 7, this box we have 2. Simple. This box we have 2. So this is how you can use the tracker, the Ultralytics object detection tracker. Okay, the by default tracker. So now, as you can see, it's detecting object with unique track ID. So we will save all the track ID along with their current position inside the dictionary. So track ID and the current position is basically their center point. So what we will do, we will simply create here, after where we have cv2.putTextRect method, here we will create hist. So hist is basically the dictionary. So here we want first create a dictionary. So hist and the dictionary. Hist dictionary, and then hist is basically, as I mentioned, the track ID. Track ID is equal to our cx and cy. So if you go here and if you print the hist, if you print this hist which is the dictionary, so you will get idea inside that dictionary we have now track ID and their current position. As you can see, the track ID and their center point, track ID 2 their center point, track ID 3 their center point. So we are saving each object track ID along with their current position. Now we need previous cx and previous cy. So for previous cx and previous cy, we will create here condition if the track ID in our dictionary, which is the hist, if track ID in hist, then we will say previous cx and previous cy is equal to our hist, which is the dictionary, and then we will mention track id. Okay, so this is what our previous cx and previous cy, history, our dictionary with the track id. Now we will create the condition if the previous cy, if it is less than line y, this line y. Okay, line y. If the previous cy, if it is less than line y, and if it is less than is equal to current cy, then we will do all these things. Then we will draw the rectangle, and then we will show the tracker. Now if I save the code, if I run the code, now watch, there is no object detection, nothing. If the object move, as you can see, we create the counter only for going this side, not for this side. Let's just say it is basically our upside and it is downside, so it's only counting the object which is going the upside. So watch, it's not counting this side, it's only counting this side. Okay, let's just say forward or up, whatever. Okay, so it's now counting only this side. Simple. So I will call which is the up. So we will create here a counter. Let's say I will create here a counter which is box up is equal to 0, and when we match our condition, I will say box up plus is equal to 1. So it will increase the counter, and then we will use cvzone put text rec method. So we install the cvzone package. So cvzone dot put t capital text r capital rect, and then we will put the text on the frame we will put the text on the frame, and then we will create the counter. So like this way, and we will mention box up, and then here we want to mention our counter, which is the box up. Okay, this one counter. Simple. So then what is next? We want to mention the coordinates. So let's just say 30 40 is the frame coordinate, the top left of the frame, and then 2 so 2 is basically the bounding box size, and 2 is basically the text size which we have inside the box. Let's just run the code. So here what I will do, I want to mention like this way. Now it's good. So now as you can see, there is a counter box up, and this is not basically minus, this is just a line. So 0 is the counter. So because right now there is no count, so when this box touches the line, counter will increase. Again the next box touch the line, counter 2. This is the third one box, counter increase 3. So now we will count, we count this side, now we will count this side. So let's just say we will simply copy paste this condition, only we will use this time. Here we use less than, now we will use greater than. So just copy as it is. Okay, check it is in line, there is no need to, okay, this we need here previous cx. Okay, so check it is in line, Now as I mentioned, yes, there is no need to mention previous cx and previous cy, because we already mentioned we only want to mention the condition. So here what I will do, I will mention like this way. So this is what our we count upside. Now we are counting the downside. So I have created the partition, and then as I mentioned previous, cy is now greater than line y, greater than is equal to cy, and then this will basically box down, and I need to create here a counter which is the box down is equal to 0. Then when we match our condition, it will increase the counter. Okay, and for let's just say for downside, we will change the rectangle color. So here we have blue color, so let's just mention pink color. Okay, and then all the things are good, and we want to put the counter on our frame. So again we will copy paste cvzone put text rect method, and then here we will mention box down, and then this also box down, and then 3140 for showing the text, showing basically the counter. Okay, so we will have now both side counter. So friends, we started our frame, and then watch here when this box touch the line, as you can see there is a false counter. It's counting the 3 box down, but right now it's going only 1 box because there is a false counter. So what we will do, you have to simply again change the line. So let me show you here what we will do. I will use the cv2.rectangle method, copy paste, and before all this condition where we have cx and cy, I will mention the cv2.rectangle method. It will show all detection, it will show us all the detection, and then where we have perfect detection. So watch this box here right now, it has only one rectangle, means it's detected perfectly over here, but when this object go over there, it has false count, or we can say it has multiple rectangles. So what I will do, I will draw the line over here. Let me start again the code, then we will get the perfect counter. Remember one thing, you have to change all this as per your requirement. Watch, this box is perfect here. Now what I will do, I will go here and I will, let's just say here, and we check the coordinates. So we have 375. So here I will mention 375. Now let's just save the code, let's just run the code. Now it will change the line because we already mentioned all the coordinates. Okay, now watch, box down, as you can see it's now counting only 1 because we adjust the line, as per our requirement, and now it's perfectly count. So watch this box, we counted downside 2 box. So when this box touch the line, we have 3. When this box touch the line, we have 4. As you can see, 4, 5, 6. So we perfectly counting all the boxes. Here this box detected, we have 7. Simple. So this is how, friends, you can create your own counter, and you can create your own custom object detection model, and you can create this kind of projects. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.